Last time we talked about the Alps, and I tried to give you an example of what people are calling a little big history, which means the big history of some particular topic. In that case, a particular mountain range that's had very important historical influences and effects. This time I want to do the same sort of thing again, show you one more little big history, and take you to one of my favorite cities, which is Rome. So has anybody been to Rome? Anybody here? Oh gosh, look at a good chunk of people, maybe a quarter of the people here. So you will understand the magic of that city that goes back 2,700 years, something like that, and has in one sense or another been the center of the world for probably 2,000 years. First as the headquarters of the Roman Empire, and then later as the headquarters of the Roman Church. So it has always been fundamentally important to Western civilization, and it's just an incredible place to go. So I think I'll give you a different view on Rome than you're likely to get elsewhere, because geologists like to look underneath. So in a certain sense, this is Rome, the inside story. And this is what I need. There you go. Okay. I like to start with this quote from Shakespeare, because I'm show you that one aspect of Rome is that it is a stage, or it is full of stages for the dramas of Italian life. So Shakespeare said, "All the world's a stage, and all the men and women merely players. They have their exits and their entrances. But if you can make your exit and your entrance on a really elegant stage, it elevates the little play that you're part of." Okay, so as you know, Millie and I lived in Libya in 1968 to 1970 at the time of Gaddafi's revolution. And for a summer vacation, we decided that we would try to learn something about archaeology, because it had always seemed interesting and we didn't know much about it. So I got in touch with a former professor at Princeton who had done geology working with archaeologists, and he put us in touch with an archaeologist. In a second, I've got to go back here and put this on so I can see what's coming. There we go. Okay, so we were in Libya, but for summer vacation, we went to an archaeological site that's not too far north of Rome, at a place called Mazzano Romano. So this is the archaeological site, and people there were doing what geologists do, only they're doing it with human history. Sung Ho, I'm sorry, that's really there's a red light that's. Yeah, I'm sorry. Excuse me. I was getting distracted by it. So anyhow, we found the work on the archaeology site to be really interesting, and then in addition, I found out that the archaeological site was right in the middle of the volcanic province that surrounds Rome, and so it wasn't too long before I decided that this was more interesting than working for the oil company. So eventually I resigned from the oil company, and we went off, and I had a postdoctoral fellowship working with archaeologists in Rome. So it was really fascinating. So here's where this place is. Here's the surroundings. So there's the city of Rome, the Tyrrhenian Sea, and here's the Tiber River. It comes down out of the Apennines and flows like this, flows right through Rome and down to the sea. And there are 4 big, quite recent volcanoes, not active, but active recently, that flank the city of the Rome. The one is down here, the Alban Hills. You can sort of see the shape of the big crestal crater with a couple of little lakes in it. And then there's the Sabatini volcanoes. You'll be hearing these names. Alban Hills, Sabatini, which has a great big lake in it. And then there's Lake Vico up here, and there's one more up there that we won't look at very much. This one here has a little peak right there, and this used to be just like our Crater Lake in Oregon. It was a lake with a little volcano island in the middle of it, but the Romans drained part of that lake I don't know whether it was against mosquitoes or for more farmland, but anyhow, the lake shore, which used to be out here, shrank. So the little volcano in the center is on a peninsula and no longer on an island. So our archaeological site was about right there. It was close to a village called Mazzano Romano, which in the 1970s was still essentially a medieval peasant village where people went out and worked in the fields every day. Things have changed dramatically. Now it's now everybody has computers and high, fast internet access and all that sort of stuff. But it's changed dramatically in that time. So I want to take you now to Mazzano Romano. And here's what it looks like. And it's built, you'll see, on a kind of a little pedestal of rock. You see the pedestal right there? We're going to see how that works. And this is going to be what would you say, a proxy for what Rome itself looks like, or looked like at the time. So we had the great pleasure of living there for a year, and our house was there. And great place to be. There's Mazzano again, and this was making wine, and this was when it got really cold in the winter. I tell you, it's really nice to have a wife who thinks this is a great place to live. And now, Mazzano, like almost any other Italian town, is kind of a stage set. And so here you can see what a great place to make exits and entrances for the drama of life as it goes on. And here's another one here. Well, that's a good place to make an entrance, and another one around there. This was a church that was built in the 16th century and was destroyed during the Second World War, but not because of the Second World War. As you can see, it sort of looks like this bell tower was starting to come down, so the civil engineers demolished it as a hazard, which always seems like a shame. But our house was, if you went around through there and back down a little corridor, that's where it was. Okay, so this was Mazzano. And Mazzano has a reasonably dramatic setting on that little pedestal of rock, but it's nothing like the dramatic setting of the next town down the valley, which is called Calcutta. And this is on a seriously big pillar of rock, and you can imagine that this was a great defensive site in the Middle Ages. It would be a very bad place if you were a sleepwalker. But these are volcanic rocks here, and now what I want to do is to take a little side tour. Remember, this is a little big history, so we're looking not just at human history, but Earth history as well. So what I want to do now is to teach you something about volcanic rocks here where you can see them clearly, because they're all up and down the walls of the valley, and that will help us when we come to understand Rome itself, which is built on volcanic rocks, but generally you can't see them because they're covered over with Roman temples and Renaissance palaces and stuff like that. So let me take you on a little field trip to see what volcanic rocks are like and what these things are, why you have this with these vertical columns on it. Okay, how many of you are interested in volcanic rocks? Anybody been out? Okay, good. So some of you have gone and seen some of them. So let me show you what the volcanic rocks of Rome look like, because volcanoes spew out all sorts of different stuff, and that leaves you with different kinds of rocks when they solidify. So the first kind we'll look at is lava flows. That's what everybody thinks of when you think about volcanoes. But actually they're not very abundant in Rome. They're a minor importance. But here is what you see if you, is JD here? No, okay, JD went to Hawaii on a field trip from the department over spring break. And so this is what you see in Hawaii. You see lava coming out of lava tubes and cascading down into the Pacific Ocean. Lava is molten rock, so when it cools and crystallizes, it's really hard. If you take the usual geologist's hammer and this is some rock, and you bang on it, it just bounced right back at you, you know. So it's really hard stuff. And so the Romans found it very useful to pave their Roman roads. Remember, the Roman roads were an engineering marvel of the time. This is one of the roads that leads out of Rome. Remember, all roads lead to Rome, but they also lead out of Rome. And so if you were to follow this back over the edge of this, we're actually inside a volcanic crater here. Down there about 25 miles, you'd be in the city of Rome. And Millie's standing along here on this Roman road that was being excavated by archaeologists at the time. And so this tells you something about the accumulation of sedimentary deposits. And some volcanic rocks you'll see are sediments. But basically, this was ground surface when the Romans built the road, and all of this has built up in the intervening 1,500 or 2,000 years. So the modern road runs right along up on there. So anyhow, that's lava. Yeah, Ryan?
I guess I had a question about why volcanic rocks are dark colored. I mean, are they still silicon dioxide?
They are not all dark. There's a correspondence between how much silicon they have in them. So the SiO2 component in volcanic rocks can range from about 40% to about 80% or 70%. And the more silica there is, then the more quartz and feldspar there is, and those are light-colored minerals, so they make the rock light. So lava has low silica, and that, first of all, makes it dark, but it also means that its melting temperature is higher, so that makes it more fluid when it's molten, so then it can flow as a lava flow. The other ones that we're going to see in a moment, which are called tuffs, T-U-F-F, tuffs have higher SiO2. They melt at lower temperatures, so they're less viscous. More viscous, excuse me. They don't flow as easily, so they tend to blow up and explode. So this correlation between color, silica content, and viscosity is a fundamental thing about volcanic geology. Yeah, you had a question.
Yeah, yes. I was wondering if it's really hard, how did they cut it into those provisions?
Well, I've wondered about that a lot. The way that they cut them into this sort of shape is because they cool and crack that way. It's called columnar jointing. And if you imagine you have a sheet of lava here, just like that. Can I use this?
Yeah.
Okay, imagine that this is a sheet of lava. Then when it comes out hot and it gets to wherever it is, and it starts to cool, it shrinks. And so it keeps pulling apart, and it cracks into these usual hexagonal or pentagonal things. What's harder to understand is how they cut it if they did this direction, because there aren't any cracks in it that way. So maybe they were using a thin flow and they put the whole column in there. I really don't know. But anyhow, good question about that. Okay, so this is lava, not very common. So the most common kind of volcanic rocks around Rome are what we call tuffs, T-U-F-F-S, and these are made of volcanic rock fragments. So the lava flows as molten rock, but these things break up into fragments, so in fact they are sedimentary rocks. It's just that the fragments in the sedimentary rock came out of a volcano. So those are tuffs. And there are at least 3 main kinds of tuffs, maybe 4. And I want to show you them because they're all really important in the Roman volcanic district. And they explain a lot about the topography around Mazzano, but also the topography around the city of Rome itself. So that's sort of the geological or the big history way of thinking about Rome, is you got to understand the volcanics. So first of all, let's look at airfall tuffs. That means that these were fragments of rock, ranging from chunks like this down to little dust-sized things that have been blown out into the air and then gradually settled down to make an airfall tuff because it fell out of the air. So here, for example, is a volcano in the process of producing fragments. So this was Mount St. Helens erupting in 1980, and this cloud going up here is a cloud of volcanic gas, but also also debris in the sense of all these little fragments of what we call them volcanic ash. And when you say ash here, remember this is not the ash that you get from burning a piece of wood. This is rock dust. Volcanic rock dust. So when this stuff falls down, when these fragments fall down on the ground, they make layers. And here you can see a couple of layers, each one of these from, remember the Sabatini volcanic district? That's the one just north of Rome. That's where Mazzano is. So these layers represent two explosive eruptions like that pile these things down. So those are airfall tuffs. Okay, now the second thing is called a mud flow tuff, because remember you got all this debris and it's fine grained, most of it. If it gets wet, it just turns into mud. And maybe right after your volcanic eruption, there was a lot of rainfall. Volcanic eruptions tend to trigger a lot of rainfall. And so a lot of the ash gets just turned into mud, and if it's on a slope, that mud just flows downhill, and that's called a mud flow tuff, or geologists use an Indonesian word, a lahar, for this. So this is what it looks like. This is a mud flow or a lahar after the Mount St. Helens eruption. Remember, this is the river that came down out of where the volcano is. And just look at this sea of mud and muck. Someplace I've got a picture looking down on that from a helicopter, and in it you can see all these pieces of trees, and then you can see logging trucks, huge logging trucks on their side or turned over, just kind of carried along as if they were a child's toy. So these things are enormously destructive. They can cause casualties, although they tend to move sort of slowly so people can get out of the way. So these things are very important. They're very destructive, but they don't usually cause a lot of loss of life unless they're ones that move very rapidly. And this is what they look like in the Roman volcanic district. This is a road cut that has just been made, and each one of these units along here is a different mud flow tuff. So you can see that these lahars were coming down one after another through this area. It was not a good place to be at the time, I guess. Okay. So the third kind now, these are the fearsome ones. These are called ash flow tuffs, and the other word that's used for them is ignimbrite. And ignimbrite is a made-up word from Latin roots, but IGN comes from fire or heat, like ignite, right? So an igneous rock is one that has been hot and molten. So this tells you these are come from igneous rocks. NIMB is a word for a cloud. So you think of cumulonimbus as a cloud, right? And then this ITE is a suffix that geologists use to mean a rock. So in this case, it's telling you these are fire cloud rocks, which, and if that sounds scary, well, boy, you better believe it is. So what they are is a mixture of ash and gas. Remember that a lahar was a mixture of ash and water. These things are mixtures of ash, volcanic ash, and gases, usually scorching hot gases that have come out of a volcano. So a mud flow flows sort of slowly, but these babies just really roll down there because it's basically gas and dust in it, and it just comes roaring down, and it can be so hot that it will cook anything in its path. So these are truly ferocious volcanic events. Yeah, Deborah?
How fast can they go?
Well, let me tell you, not that many observations have been made on them. Or maybe I should say, we don't know how many observations have been made because the people who make the observations rarely survive. So we simply don't know a lot about the details of it. But fast. I mean, you couldn't outrun one of these babies. Okay, so here, for example, this is when these first began to be discovered and understood. This was from an eruption of a volcano in the Caribbean called Mont Pelée. And so this, I forget what year the eruption is, but this shortly afterwards, this was a book about it. It was published in 1904. And what happened, there were several of these over a period of a year or two. And so after the first one happened, the French volcanologists went rushing down there to see what was going on, so they got these pictures. So this is a picture, and the guy who took this survived because he was not in that valley over there. But the fire, ignimbrite, or the what do you call it, the mixture of gas and ash has just been erupted there, and is starting to roll down a valley that's just out of sight there. So these are sequential pictures. You can see it moving down, and down on in the bottom of the valley is this mixture of dust and hot gas that's moving very, very fast. But from the top of it is a sort of a turbulent cloud is lifting off of it. So this stuff here used to be down in the flow, and it's kind of been roiling off as this hot cloud rising. So down in that valley, nothing is surviving. And here's another example from a volcano in Guatemala, again, fortunately taken by somebody who wasn't in that next valley. But this is sort of what's happening above it, but the real serious stuff is happening down in the bottom of that valley where this ash flow is going. Yeah, right. No, Phil? The reason is that if you have gas with a lot of dust mixed into it, then the density is somewhere between the density of the rock material and the density of the gas. So that means that its bulk density is greater than the density of air. So that's why it flows down the bottom. Yeah, David?
In addition, there's actually someone in this department here who studies how these flows travel and propagate, and they found that this particular type flow can keep rock airborne over miles and miles and miles. Basically, seeing it as it's sort of like a jamming problem where the rocks bounce down and they come back up, and because it's such a high magnitude and there's a lot of velocity involved with the flow, it can keep pushing up more and more rock. And so these things will be just like a wall of rock that flows for miles. And they can flow out to sea and deposit all over the place.
Yeah, these things were only came to be understood about 1950. Before that, people would see the deposits and they would say, what on earth was that? How could that possibly exist? And it wasn't until people began to realize what had been happening at Mont Pelée, and then they started to see a few like this one in Guatemala, that they really appreciated what an ignimbrite was. So here is an example of an ignimbrite in Italy. This is a road cut, somebody's laundry up there for scale. And you can see that this thing is hard. And you might ask, how can you have a rock that was just made of volcanic fragments carrying along? How can it be so hard now? I mean, this one isn't quite as hard as hitting, as the lava flow, but it's harder than you would expect. And the reason is that the gas was so hot that after the thing came to rest and the particles settled on top of each other, they were still hot enough that they kind of fused together. And so sometimes these things will be what they call welded tuffs, which means that the gas was so hot that those fragments just kind of got soft and squishy and sticky and stuck together. So this is an ignimbrite or an ash flow tuff. So that's what is around. But then there's an additional thing, and that is that if there are streams, rivers, or lakes in which some of this volcanic ash falls, then it gets moved around just as any ordinary sedimentary rock would. And so those are called fluvio-lacustrine beds. Fluvio comes from river, fluvial means river-like, and lacustrine has to do with lakes. So these are beds, mostly volcanic tuff, redeposited by streams and in lakes. And so here's an example. This is a quarry from near Mazzano, and at the time they had been extracted extracting, they've been getting this volcanic ash out of here. It's very useful, by the way, in making cement. The Romans learned how to make cement out of this stuff and mix it with lime. But at any rate, this, you notice here, these beds are not horizontal, smooth beds like Steno talked about. These have got this sort of sweeping down there. This is actually a cut through a delta, a little delta, where a stream had poured into a volcanic crater lake. And so just like any stream, it made a delta, but it's just that the delta here, the material is made out of fragments of volcanic rock. So that's the kind of rocks there are. And now I want to show you how they work to make the topography of a place like this what it is, because it's very characteristic. We have something we call inversion of topography, and you can see how that works. Imagine that there was here's some pre-existing, probably soft rock of some sort, and a stream has cut a valley in it. Then there's a volcanic eruption, and you get a flow, and the flow might be a lava flow, or it could be an ash flow tuff. And since it's density is carrying it down, it flows down the bottom of that valley and fills up the valley like this. Then after that event is over, erosion continues, and if this is harder than that, the white stuff will get eroded away, and you'll end up with a ridge like that. And the ridge will actually follow, it'll be a sort of elongated sweeping ridge that follows down wherever the valley was. Any of you ever go up to Yosemite and go through China Camp? Have you seen Table Mountain? Any of you seen that? It's a perfect example of this, where lava flow filled the valley, and then the sides of the valley have been eroded away, and the lava flow continues there as this sort of a sweeping, meandering thing. So that's pretty easy to understand, but it can get more complicated. So here's a more complicated case. So let's imagine we have rocks of 3 different resistances to erosion. So the weakest is this original stuff here. Sorry, come on. Well, I'll point to it because the pointer isn't working. Okay, so this is the softest, most easily eroded stuff. And then imagine on top of it there was a hard lava flow in place. We'll say this green one is a lava flow. And then that gets cut away by a stream at a certain point. It makes a canyon. So because it's hard, it's got a steep wall over here and then a gentle slope in the soft stuff. So that's what the valley looked like at a certain point when another flow came down there, which is sort of intermediate. So if this is a lava flow, maybe this is an ash flow tuff, which is resistant but not as resistant as the lava flow was. And then after the next stage of erosion, it erodes away some of this thing and leaves a new valley here, but some of this ash flow tuff is left on the side. So this is kind of a sort of a complicated inversion of topography, and that's what you see in the area right around Mazzano. So here is Mazzano, and it was on a little pedestal here, and that pedestal in yellow is the same as this one. And all along the valley here, you'll see there are little yellow pieces that come along like this, here, over here, here. And this one, see, this is the pedestal that Calcutta is built on. That was the one where you didn't want to be a sleepwalker. And so if you look at where all of those remnants of this unit are, you can sort of trace out what the old valley used to look like. And here's a couple of side canyons come in, and they join here. And so that's what the pale yellow here is what the valley would have looked like on the day when the yellow unit was erupted. And now some of it's left, and it makes great places to put little medieval towns like Mazzano and Calcutta. Anybody got any questions about so far? So this is, yeah, Josh.
Is the southwestern United States with mesas and things, right?
Those tend to be simpler because those mesas, say in Monument Valley and places like that, those are eroded off of great parallel sheets of rock that don't have this kind of topography cut into them and filled. This is here's a good piece of understanding, that in the oceans oceans are dominated by deposition of sediments. That's where all the sediments from the rivers end up, right? Mountains are dominated by erosion because that's where the high peaks are and the glaciers and the steep active streams. So mountains are dominated by erosion, oceans by deposition. Volcanic rocks have the most intense balance and interaction because you're constantly depositing volcanic stuff, or not constantly, but every now and then there'll be an eruption and it will deposit some stuff. And then erosion takes place because it's above sea level, then more deposition. So that's why you get this enormous complexity. Okay, so now, I guess just to kind of put that together, so here's Calcutta again, and that view is taken from this road looking down at it. So there's Calcutta, and this is the wall that was up higher. So you see that on the far side, that was up higher, and then there was a valley cut through all this stuff. And this is the youngest portion that's sitting down in the valley. And this gives us now some understanding of what the volcanic rocks are like in a place like Rome and what went into forming the topography of the city of Rome. Remember, Rome is built on 7 hills. And some of the hills have origins like Calcutta. So let's go to Rome. So here we are again, this place. And boy, talk about a place that is stages everywhere. There's the Piazza Navona, which is one of the great ones, but what a place for the drama of life to take place, right? Okay, so we had been there in 1970-71, that winter, and while we were there, I had met an American archaeologist named Albert Ammerman. And we'd become friends, but then we sort of lost touch with each other. And one day, I was sitting in my office here in this building, I got a telephone call. And it was Albert, and he said, we caught up on things, and then he said, I'm doing a project in Rome to try to figure out how the topography of the city evolved. All the time it was a city. What changes took place to the original natural landscape? He said, I need a geologist to work with me, and I know that you know about these rocks. Would you like to do it? Well, it took about 10 seconds to say yes. And we had this most wonderful project there for quite a number of years, and I want to show you some things about it. So there's Albert. And Albert knows, he knew all of the archaeologists in Rome. This was kind of fun. This is full of, the Forum, for example, is full of archaeologists from different Roman universities or Italian universities and elsewhere around the world. And for the most part, they don't like each other very well. And so if you were working for me and my excavation, you would not be allowed in the excavation that Ryan was running, and David's excavation wouldn't tolerate any of us. So that's sort of the way it was. But Albert knew everybody, and so we had access to all of the excavations, and it was really great. So now I want to show you something first about archaeology of Rome, and then about the volcanic country. Okay, Albert's research question. First of all, what did the site of Rome look like before the first settlements? And then how did the city evolve topographically through the centuries? This is a photograph of a plaster of Paris model. It was made in the fascist times in the 1930s of Rome. So you can see the Colosseum sitting there. And the famous parts of Rome for ancient Rome are, of course, the Forum, and then this hill over here called the Palatine Hill. And it's called that because, or from that name came the word palaces, because that's where the emperors had their palaces after Rome became an empire. So imagine now that you're sitting on this little hill, which we'll see in a moment, looking down this direction. The Colosseum will be at the far end, and on the right is the slope up to the Palatine Hill, and there's that view. So we're sitting on the little hill in the foreground. Yeah, you?
I'm sorry, can you go back 2 slides?
2 slides?
I just don't have the questions there. Thank you.
I'm sorry?
Right there.
The questions?
I'm not sure if other
Oh, they didn't come through? I'm sorry, they may not have shown up. The questions are, what did the site of Rome look like before the first settlement? And how did the city evolve topographically through the centuries? Thanks for bringing that up. Okay, so here's this view, and in the distance, that's the Forum, the Colosseum down there, and then this is the Forum, and there is the Palatine Hill. And you'll see the Forum is a kind of a valley, and in fact, the name Forum has the same root as our English word perforation, meaning a hole. A perforation is a hole. In this case, it's a hole in the sense of being a valley. And so this is where the Romans had their public buildings. They were sort of in between the Palatine Hill over there and then the Capitoline Hill, which we're standing on to take this picture. And there was, in those days, an excavation by Professor Carandini from the University of Rome. And he was looking on the edge of the Palatine Hill. And the reason was he was trying to get to the oldest part of ancient Rome. So this was a good choice, because if you did an excavation here in the middle of the Forum Valley, you're going to go down through layer after layer after layer of Roman stuff and early Roman stuff and pre-Roman stuff, and you'd never get to the bedrock underneath. Up on top of the Palatine Hill, it's probably been all eroded off and it's covered by palaces. So Carandini thought that on the slope here he might get to the oldest deposits of early Rome, because that's what he was interested in. So here's his excavation in 1988, and so you can see they've dug down there, they're down in all that water in the bottom. The guy in the blue shirt in the lower right was a grad student who was working with Carandini and also with Albert, and so he became a great colleague of ours doing this work. And here's two Berkeley grad students, and they are up against, you can see the remains of a wall. Can you see that wall down there with the big blocks of rock in it? Well, Carandini identified that as the wall of Romulus. So if you remember, Rome was founded, according to legend, by two brothers, Romulus and Remus, and they had been somehow abandoned, and they were suckled by a she-wolf and raised by her, and then they started this settlement of Rome on hills that were out in the countryside. There's no city there at the time. So the traditional date of the founding of Rome is 750-something BC. So long ago. And the tradition in those days was, if you founded a new town, they'd put it on a hill for defensive purposes, and they would take a plow and they would plow a furrow around the top of the hill, and the furrow would be the beginning of a defensive moat or ditch, and then the dirt from the plow would be thrown up on one side, and that would be the beginning of a defensive wall, and then they would build a wall on it. And so the ancient traditions of Rome say that Romulus built this wall around the top of the Palatine Hill. And people had thought for a long time that that was probably just a legend. But when Carandini found this wall there, he could tell that it was the right age, because it was associated with pottery of types that were known to be from about the time of Romulus. And so he christened this the Wall of Romulus, and of course archaeologists love to fight, and so there were great debates and arguments about it. And I've had the pleasure of reading what Carandini wrote about it later. There's some remarkably intemperate Italian written about some of his colleagues. But anyhow, that was the Wall of Romulus, and it was discovered. We'd actually had been in this site just before they discovered it, and then we came back shortly afterwards. So it was a time of great excitement, and it really hit the newspapers. So here is the Roman newspaper says it was Romulus who founded Rome. That myth is now a reality. And up above is the San Francisco Chronicle, so you can see that this story went viral in a day before there was an internet, and it was a big thing. It was really exciting to be involved with. But the problem was that this was the only little bit of pre-Roman topography that they found in that excavation. You couldn't find anything else elsewhere in the Forum if you were interested in the earliest Rome, which Albert was. You couldn't find it in the Forum because it was buried. You couldn't find it on the Palatine Hill because it was covered with palaces. And so we ended up going to a different spot. So there's the places that we couldn't work, Palatine and Forum. They just weren't going to help. So we ended up going to the Capitoline Hill, which was down here, which is a smaller hill. And this was the center of Rome in Roman times. Anybody see that sequence, that series of television programs about Rome a few years ago? Did anybody see that? Was it what?
HBO series?
Yeah, I think it was HBO. I only saw one of them, but anyhow, that's putting flesh and bones on flesh and blood on the sort of bones of what we were seeing then. So now I want to tell you about the Capitoline Hill because I came to just love this place, and not too many geologists have the chance of doing their geology in such a fundamentally important historical site. So let's look at it. So it's shaped kind of like a peanut or a short banana or something with this, and I'm going to have to go point at these things because I've lost the laser pointer. So here we go. Okay, so it's kind of shaped like a peanut, and try and get this picture in your mind because we're going to get to know this in the next few minutes. So it really has two summits. There's a high part here and there's a high part here, and in between is a sort of a lower saddle, and that's where Michelangelo's famous piazza was. You know, he was not only a sculptor and a painter, but he was also a great architect. So what I'm going to do now is to move from north to south, just introducing you to the Capitoline Hill. So up at the top it says Monument to Victor Emmanuel, and that is here. So anybody who goes to Rome looks at that, and I don't know, maybe you had my foolish reaction when we first went to Rome. I thought, my gosh, that Roman building is really well preserved. Well, the reason it was well preserved was it was built about 1900 and in Roman style as a monument to Victor Emmanuel II, who was the king of Piedmont in northern Italy, who really reunited Italy in the 1860s and 70s. And here is a picture taken from a balloon while it was under construction. So it faces this way. See there, it's facing that way. We're really looking in that direction in this picture. So the rest of the Capitoline Hill is around over there. Michelangelo's piazza is here. I want you to look, if you can see this, those of you who are close enough, right down here are two buildings, and it almost looks like a building that's been offset by the San Andreas Fault, like this. And so keep that in your mind because we're going to come back to that later at some point. Is that not?
I'm going to put the light and put the batteries in.
Good, good. Oh, that's great. Thanks. Appreciate it. Okay, so that's the north end of the hill. This is the monument to Victor Emmanuel. The Romans call it the Vittoriano, and tourists often call it the wedding cake. But it's the most dramatic, recognizable thing on the Capitoline Hill. So then, now let's move down here and see this medieval church called the Araceli, and then Michelangelo's piazza. So if we go down there, here's what that looks like. So here's the back end of the Vittoriano. In this picture, we're sort of looking in this direction. And so the Araceli is this medieval church up here. And then there's this wonderful piazza with this intricate geometric design filling an oval there, and three palaces that were all built by Michelangelo. So that's his piazza. And then to the south down here, there are some government buildings. All right, so thank you. Let's see if it works. Oh, bravo. Thanks, David. Okay, so now this gives us a chance to see what it looks like now and compare it with the way it looked in Roman times. Okay, so here's the modern map that we've been seeing, and here's the way it looked in ancient times. So the saddle was there. There were two hills here called the Arcs and the Capitolium. And on the Capitolium was the Temple of Jupiter. And this was the most sacred holy place in Rome in ancient times. This was where they would have, if an emperor won a battle against those nasty Germans, for example, and they had a triumph in Rome that would finish up with going up there, and then there was over here where it was a steep cliff, and sometimes people would be executed by being thrown off of that cliff. And then there was a saddle here, and then on the north side was the Temple of Juno Moneta. And moneta is Italian word for money, and this was the mint. So the coinage, the Roman coinage, was made in that temple. Then over here was something called the tabularium, which was the records office. This was the bureaucratic center of Rome, I guess. And it was partly built as a government building, but also it's massive because it was a retaining wall. Because this saddle had soft sediments in it, and they kept slumping down into the forum, and the forum is down here. And so this record office was built partly for records, partly as a retaining wall. And then later, you see Michelangelo built one of his palaces on top of it. So Rome here is, I think, a wonderful metaphor for the way we read history, both archaeologists and geologists and paleontologists, by one deposit piled on top of another. Okay, so here is a photograph of that plaster of Paris model, and it's sort of looking in this direction the way it would have looked about the time of Constantine, 300 and something AD. So here's the Temple of Jupiter, and here is the Mint. There is the saddle right in there, and the record office would have been right there. And then to the right is the Forum. So, ask the question, how did the Capitoline Hill come to be the way we see it today? Because it was very different in Roman times. In fact, virtually all of the buildings on it are new, and it's really fun and interesting to figure out how those changes came to be. So what I want to do is to show you this in terms of a little mystery that intrigued me for a long time, and it was great fun to figure out the answer to it. So here is the mystery. This is a watercolor that was made in the second half of the 19th century by an Italian artist with a German name, Ettore Rössler France. And the title of this view is the Via Giulio Romano. And if you look at it closely, you can see that street sign says Via Giulio Romano. And when Millie and I lived in Rome, we bought a reproduction of this just because we liked it, and it's been on our wall for a very long time. And every now and then I would wonder where that was, because I never heard of it, Via Giulio Romano. That street was not familiar to me. So I started wondering where it might be, and then I looked in every map I could find, and there was never a Via Giulio Romano. I went back to the 19th century tourist guidebooks. No Via Giulio Romano. The breakthrough came when I discovered this map, this was the first accurately surveyed map of Rome, and it was done in 1748. And it doesn't have the Via Giulio Romano on it either, at least not labeled. Now, just so that you remember those two buildings that were offset by, looked like they were offset by a fault? It's these two there, this building, and the street going through almost looks like it's been shifted by the San Andreas Fault, but they were just built that way. Okay, so I started thinking maybe the Via Giulio Romano might be on this. And so let me show you what's there, because it was really fun to find these things out. So here is the Church of the Araceli. That's the one that's just in back of the huge white Victor Emmanuel monument. So that was there in 1748. And here is something called the Palazzo di Venezia. That's is a government building. Those of you who remember maybe having seen pictures of Mussolini giving speeches in the Second World War, his balcony he gave those speeches from was right there, because all this stuff has been cleared out, and this is a great big piazza, and the multitude would throng here to hear the great man jut out his chin and give militaristic speeches. But at the time of Nolli's map, this was a papal residence, so the Pope lived in here. Not at St. Peter's, but here. Isn't that interesting? Oh, this outline, by the way, this is the outline of the north end of the Capitoline Hill. So remember, the Articelli is up there. Okay, now, what else is there? Well, the Pope had a summer palace on the Arcs. Remember, ARX was the name for this northern summit on the hill? And why would he do that? Well, I'll tell you, if you've been in Rome in the summer, you know, it's just beastly hot. And there were a lot of swamps around at the time, and it was full of mosquitoes, and it was badly malarial. And mosquitoes don't fly very high, so if you could get a little bit higher out of the mosquitoes, you had less chance of getting malaria. So even though it's only, 100, 150 feet higher up on that hill, the Pope had his summer palace up there. I'm sure that the air was, there was the more fresh air, and it just was better. So that's where the Pope would go. Now, it wasn't a long walk from here to there, was it? But if the Pope was going to walk or be carried up through there, he was going to go through the streets where the ordinary people were, and that would just never do. And so the Pope had a special viaduct, a special walkway that started from the papal palace, and it went up a slope to the normal residence up to the summer palace like that. And I thought that was kind of cool. What else? Let's see what else there is. So what I'm going to show you in a moment is that with all of this in mind, you can find out where that street was. And the Via Giulio Romano was there. And it went through here, and it was the street that seems to offset those two buildings. And the way I can really be sure, I'm going to show you how nicely it matches, but the other thing that matches, see up there is the dome. Let me back off so you can see it. See the dome up there? That's the dome of a particular church. And so now let's leave this on the right-hand side, and on the left-hand side, let me show you that picture again, and you'll see how it all ties together. So there it is. So I'm pretty sure that the artist was sitting at this intersection, looking in that direction, that this little side street was this little side street, that the viaduct was up there, because if you see the full picture, I managed to cut the top off the picture, but up above you can see that there's sky above that, so it's just a little walkway up there. And here's where the Pope could stop and look down at the people in the streets below. And if you look down here to where if you were right there, as you look down on the right-hand side of the street, you would see the front of that building facing you. That would be this. And then the side of that building down there. And in the distance looking over it, there's the dome of the church. So it was so much fun just to find out where the artist was actually standing when he painted the picture. But all of this is gone now because it was removed when they built the Victor Emmanuel Monument. And, I know, I've got a couple things here just to show you what it was like when they were building it. Okay, so here's the building process. So we're now going to be over here someplace looking in that direction. Remember, there was a papal palace here that was torn down when they put in the Victor Emmanuel Monument. And here's the way it was before they started the construction project. Here's the Articelli Church. And this now is where the Victor Emmanuel Monument was, but this was the papal palace at the time. And in this one you can't see the viaduct because it's down a little bit lower, but I think the next picture you probably can. Okay, the next picture is taken during construction from a little bit further, a little bit lower down the hill. So now they've torn down all the buildings down in here, but they left the viaduct for a while because it was very useful to them for the construction process. But here you can see it, and in fact, this window right there is visible in the picture of in the watercolor painting. So The viaduct was then demolished at the end of the project, and now here is the monument nearly completed. They've taken down the viaduct, and they're in the process of completing it. So that means that if you had been there in the middle 19th century with the watercolorist, this is what you would have seen. If you were to stand on exactly the same spot as this lady and her little girl are standing and turn and look in that direction, if you did that today, this is what you'd see. You'd see the monument there. Okay, so now I have a question for you. What's the purpose of this building? Why would you build it? Nobody lives there. Anybody got any idea why you do it?
Was that done during the fascists?
It was pre-fascist. It was finished before the fascists. Well, remember what Rome is all about in one way? It's a stage. So in fact, all the Victoriano is a stage, and here it is in use for some great public celebration with the Air Force flying over in red, white, and green smoking jets, and ceremonies taking place, and soldiers standing up and down. So this is sort of the ultimate stage of the city of Rome. Okay, now, I want to show you a little bit more about this. And pretty soon we're gonna finish off by seeing what's inside the Capitoline Hill, because that's what geologists want to know, and that's what Albert wanted to know. And we were really able to figure it out in the case of the Capitoline Hill. So here's the way it is today. And remember, this is all higher, and the Forum is low. Perforation, remember, this was a low valley there. And so if you were to stand down in that valley and look up at the Capitoline Hill, somewhere in the late 19th century when photography was getting started and they had early photography, if we're down in the Forum, if you look at it, here's what it looked like at the time. And this was when the Forum was an oxen market. It was not the great archaeological site it was today. This was when Rome was still, had not become a great center of anything. It was really still in medieval conditions. This is the tabularium, the back of it, the Roman record office. This is the palace that Michelangelo built with a bell tower on it. So Michelangelo's piazza is on the other side of this building. The Arta Coeli would be there, and the Victor Emmanuel, which had not yet been built, was over here. But other than the fact that I think it's really cool that there was a time when they were selling oxen in what's now one of the greatest archaeological heritages of the world, the other thing I want you to notice now is that there are little houses all over here. Because in the 19th century, there were medieval houses that kind of climbed up the side of the Capitoline Hill, and people lived there. There were, apparently from descriptions, there were wonderful little medieval neighborhoods and little places where you could go and get a sandwich and stuff like that, or buy whatever you were buying in the Middle Ages. And all of that got torn down. So here is a sort of another stage in the topographic evolution of this city. So this stuff all got torn down, and it got torn down. Oh, Alex, you asked about the fascists? The tearing down was done by the fascists. The fascists came to power in 1922, and they lasted until the Second World War in 1944. But Mussolini was the head of that, and what he wanted to do was to glorify Roman history as a way of getting the Italians to be more militaristic and go out and stomp on their neighboring countries. So here is what they called the isolation of the Capitoline Hill, and by that they meant they were going to get rid of those little villages that were around, the little neighborhoods, and leave the Capitoline Hill in its pristine glory. So here's the Victor Emmanuel monument up there, which, see, it was built now about the turn of the century. We're now in, 29, okay, 1929. Here's the Arta Coeli, and these are these little buildings that were all over the Capitoline Hill, and they were being torn down then in 1929, and here is Mussolini right there with a group of dignitaries inspecting the Capitoline Hill after all of these buildings had been removed. So I guess my point here is that any great city has got a history to it, And any city that's as great as Rome and as ancient as Rome has got an amazing history behind what's there at any given time. Our campus does too. And but I want to show you what now is inside the Capitoline Hill. But first, why don't you take a moment and just breathe deeply. Maybe they've stopped vacuuming and we can leave the door open now. Okay, are you ready for the inside story? So here we go. Okay, so what we wanted to do, Albert and I, was to find out what kind of rocks had been inside the Capitoline Hill, or were inside the Capitoline Hill. And it was hard to do because it was covered over with buildings and monuments and churches and gardens and things like that. So we started out in the southeast corner of the Capitoline Hill because there was actually an outcrop there. So these are actually rock outcrops. In this case, this is concrete and stuff like that, but this is really rock. And this was exposed because this was where Mussolini's people had torn down some of the buildings that surrounded the hill. So this was probably somebody's wine cellar inside a house that stuck out maybe to as far as here. And all that stuff was torn down just to make the Capitoline Hill look the way Mussolini thought it ought to look. And so geologists love outcrops. And when we looked at that, we could see different layers. So we're thinking geology in layers now. So this one says this is the Capilacho. This is a mud flow tuff. So this was the result of a lahar, one of those water and ash flows. And so this was one that Albert knew about from around the Forum. It was used for building stone very early on. And then above it was an ash flow tuff. So we're building up a little stratigraphy here. And these colors, the purple for Capilacho and the orange for this ignimbrite that's called the Tufo Leonato, I'm going to keep using those. And then above that were fluvio-lacustrine deposits. So all of these are telling you something about the volcanic history of these hills, of what became these hills. And then finally on top of it is let's see, did I jump? No, that's okay. Above that is what are these building things here, which Albert always referred to as the archaeology. So this is the geology and this is the archaeology. And that's where you started. And geologists, like to sort of simplify because, each one of these layers is a big, extensive layer that goes for hundreds of meters or kilometers or something like that. And they don't change very much in that direction, but they change a lot in the changes in the vertical direction. So we make these things that we call stratigraphic columns. This is like an imaginary well. In other words, if you were to go up on top of the hill right there and drill a well, this is what you'd see. So we make these things called stratigraphic columns, and they're going to help us to see what's going on. Okay, so what I want to do now is to take that stratigraphic column and I'm going to shrink it down here into a little one so that we can build up across this. We're going to build up across here a picture of what's inside the Capitoline Hill. So that was the first outcrop, and then there were two more outcrops there and there. And they let us see a little bit of what was going on. So here is the orange, that's the ignimbrite, and here's the mudflow tuff in purple. And this sort of a slope in there, so there was a little bit of topography that this ashflow tuff came down on. And this is what it looks like in the field. So we're standing there, and this is the contact running right through there. So this is the Capilacho, the mud flow tuff, and then this is the ignimbrite above it. And that was all great, but the problem was that that's all there was to it. There weren't any more outcrops. And so I've kind of figured, well, that's sort of the end of the line. Where we saw a little bit, but we'll never figure out what's inside that hill. Well, Albert had a way of getting a little more information. You see, Albert is a big, strong guy, and he liked the exercise of turning an auger like that. And there were always people willing to watch him work. And so he could auger down through soil. Well, he could auger down, I don't know, maybe that far, something like that, and get down. Sometimes he could pick up the top of whatever the bedrock was underneath. So we got a little bit more information out of that, but it was really pretty, there's no way we were going to find out what was in the center of the Capitoline Hill. Until one day I got this back here in Berkeley, I got this excited call from Albert. You know, the project had been all over for 2 or 3 years, and Albert called me up and he said, Walter, we've got to go back to Rome. The city government of Rome is drilling engineering test holes all over the Capitoline Hill and parts of the Forum with a machine auger like this, so they can go right down through the rock. And the reason they were doing that was that they were worried about the stability of the old Roman ruins, because there's buses and trucks and stuff clattering through the streets and vibrations. So from an engineering standpoint, they were worried about whether those buildings were going to last. So he said, and there's cores everywhere, and they aren't using the cores. They just look at it and make some tests on how strong the rock is, and they throw them away. So we got over there as fast as we possibly could, and we got to do this. This is great fun, doing drilling in the courtyards of Renaissance palaces and things all over this part of Rome. Most geologists don't get to do this. I feel really fortunate. And then it turned out that they'd taken all of these cores and they'd put them in boxes, and then they didn't know what to do with them, so they were stacked all over the Capitoline Hill. And so here's your professor, just as happy as a pig in mud, almost literally, with boxes of cores everywhere and all measured down. There's a ruler for scale, just finding out what was down in there. And they were all over the Capitoline Hill. So suddenly we had this ability to find out what was down there, and we could now start expanding. So here's where we left off, and that's all the outcrop there was. And when we started getting access to cores, we got some more. Here was 2 cores over here, and we could now see more stuff there. We could see that under the Capolaccio there were volcanic sediments, and under that was the gravel that had been deposited by the Tiber River, which is only 100 meters away down the street from this. And let me just go back. See, that's what we knew before. We just had those 2 units. Now we got 4 of them there. And this is Michelangelo's Piazza. And the gravel down here looked like this. And it's just these chunks of limestone, and they are all limestones that have been brought down out of the high Apennine Mountains and deposited here in Rome. And when we studied those things very carefully, and there's no volcanic grains in that gravel whatsoever. So we're looking at what Rome looked like before the volcanoes turned on and started putting volcanic minerals in it. So these were there. And go back to this now for a moment. And, well, we want to fill out what's in here, right? So what we could see was that above the Tufo Leonato, there was the fluvio-lacustrine deposits, and then this was Albert's archaeology. So this was what we could see right about that place where we started and close to it. But there was more, and so I've got to make room to show you what there was. So let's see now what happened when we started looking at new wells. Here are 3 wells, and of course we measured all of these in the core cuttings, and kind of looks about the same, doesn't it? As you look here, you see the Tufo Leonato goes over. The fluvio-lacustrine must have been across the top of it, but it's been eroded away and then covered by archaeological things. And this one continues, and this one continues, this one continues. Doesn't look very exciting, does it? That's what a geologist calls layer cake stratigraphy, in which you just have one bed after another. Kind of, Josh, this is what it looks like in Monument Valley, where the geological units go on and on and on. And then we got a surprise, because the next well was completely different. You ready for this? It looked like that. Aren't you astonished? Yeah, okay. At any rate, what you can see here is that in this spot, the tufo leonato goes way down thicker. This probably doesn't make any difference. That's just what the young erosion is and where the Roman buildings were placed on top of it. But the important thing here is that the Cappellaccio ends between this well and that one, and the volcanic sediments end between this well and that one. So that means that on the day when the tufo leonato ignimbrite was deposited with that great clouds of billowing ash above it, it found itself in a valley here, and this was the side of the valley. So if you'd been out there a week before the eruption, you could have wandered around here and taken samples of the volcanic sediments here and climbed up the hillside a little bit more, taking samples of the Cappellaccio. It's probably not as steep. I've kind of squashed it a little bit, so the sides weren't that steep. But at any rate, this is what was there on the side of a valley, and then it was filled in by the tufo leonato, and not only filled in, there was so much tufo leonato it even went up over the surrounding countryside outside the valley. And we kept looking at these, and it continued on. So here's another one, looking the same right here. You can see that this stuff had been eroded away all the way down to the gravel, so that here you have tufo leonato lying on the gravel. So this is the kind of historical record that geologists read when we're reading Earth history. It's this sort of process. And finally, when we got way over here, we came to the end of the hill, and we still hadn't gotten outside of this valley. So we had discovered an ancient valley that had been cut before the time of this tufo leonato and then filled by the tufo leonato. Okay, now how do we make sense out of that? Okay, so here's a map of the south end of the hill. Here's Michelangelo's Piazza, and this is the foundations of the Temple of Jupiter up there, and our original little outcrop was down here someplace. And so what I'm going to do to show you how this works is I'm going to color all of the wells purple that had this purple Cappellaccio in it. Yeah, Matt?
What are those 3 white chunks?
Oh, good for noticing that. Hold off a minute. We're going to see that in a minute, but that's really good. Those are holes. There's nothing there. No rock. Okay, so anyhow, all of the ones that have Cappellaccio present, I'm going to label them purple and put them on the map down there. So I hope you can see from the back, but they're basically all along the east side of the hill. And then all the ones over here where the tufo leonato is thick, we're going to make those orange. And they come here in this area. So basically what that's telling you is that the east side of the Capitoline Hill was up where that uplands was. And then the west side of the Capitoline Hill is here where the valley was. So that was filled. Okay, now we'll come to Matt's question. What are those holes doing there? Those are places where when the driller was drilling, as he was drilling down through rock, and all of a sudden, whoomp, the drill string dropped like about 3 meters or something like that. The Roman dialect is full of the most colorful expressions you can imagine, and I would imagine the driller used them at that point. What are they doing there? Why are there holes in the inside of the Capitoline Hill? Well, what we found out was that they are something called latomie. We did not know about that, but they were underground quarries in which people were quarrying out that ignimbrite of the tufo leonato because it was very useful as a building stone. It was strong enough to make buildings out of, but still weak enough that you could cut it easily. And during the Middle Ages, when Rome didn't control the whole world, it didn't even control the countryside outside the walls of the town. If you wanted to get building materials, it was much better to get them from inside the wall than to go outside and have a chance of being captured by bandits. And so they were getting their material out of the inside of the Capitoline Hill. And in fact, in the Middle Ages, wherever they could, they made use of old Roman buildings. So for example, if you've seen the Colosseum, you might have wondered why it has the pox and has all of these little holes in it in here. Actually, the Romans had used lead plugs to lock the stones of the Colosseum together. So you put one stone here and putting another stone. You don't want it sliding around in an earthquake. So what they did was on the top of the underlying one, say this is the lower one, they dug a little patch, a little hole, a little hollow, maybe this big around, and then on the block that was going to be above it, they had on the bottom of the block they made a matching recess so that they would go together, and then they drilled a hole down through the upper one and they poured molten lead into it, and it went down, filled that lock, the lower and the upper indentations, and made a little lock that got everything together. And so during the Middle Ages, when they needed lead, they would just go and mine the Colosseum. And so that's what they were doing, and they were doing the same thing inside the Capitoline Hill. And so this is us inside the Capitoline Hill taking measurements. It was really hard to get permission, but we finally got to go in there. And here's a page from my field notes with this is the surface, and we had to match the map. There was an old map of where the underground workings were, and so it was really fun doing our field work inside there. So here's the situation again. Yeah, quick, Alex, because we're almost out of time. Yeah.
What about the dates? Like, when was the pre?
I'll show you in a moment. Show you the dates. Okay, so anyhow, this is our picture again. This is this valley, and there it is. Ancient, must have been the ancient Tiber, because the Tiber is only a few hundred meters away from this at the present time. The Tiber must always have flowed through there, and whenever there was a volcanic eruption, it would block the Tiber and dam it up, and then it would take a while to erode through it, and then it would make a new channel. Maybe it would move over someplace, and then that would get filled by volcanic rocks. Again, it's this thing of volcanic areas being the place where you had the most intense interaction between erosion by rivers and deposition by the volcanoes around them. And so now if you look at the whole of the Capitoline Hill, this is what it would have looked like 518 plus or minus 6,000 years ago. And the reason we know that is that these, you can date the volcanic minerals, and those were all done up here at the Berkeley Geochronology Center. And so picture this is what, here's the arcs up there, there's Michelangelo's Piazza, and here's where our original outcrop was. So this would have been covered over by the Capilaccio mud flow 518,000 years ago. And then west of this line, a valley was cut through. The Tiber must have gone through there. I don't know whether it was heading north or south, we can't tell that. But then that valley was then filled in by the Tufo Leonato, and that's dated at 353,000 years ago. And then up here in the north was another valley that had a lake in it, and I've left that out just because there isn't time to tell the whole story. But it was in here, and that's the date on that. So we really can see what was inside the Hill of Rome. So when you go there now and look at it, here you are looking up from the Forum. This is the back of the Victor Emmanuel Monument. Now we understand what's inside this hill and how it evolved and how it came to be. So in summary then, Albert Ammerman's question was, what was Rome like before the Romans? And we found that the Roman volcanic rocks from the Trea Valley have rare basalt, lots of volcanic ash of different kinds, often with valley cutting and topographic immersion. And finally, the Capitoline Hill itself has seen volcanics filling old valleys of the Tiber, seen in cores and underground quarries. Final thought, all Rome is a stage. Thank you.